Good morning, grade 5 students, and today we're going to do an experiment. We're going to explain why particle size can be useful in separating solids. So there's a few things we need for this experiment. We need a bowl to catch all the stuff that we separate out, a sieve, and a sieve is like a net and it has very small holes so things can fall through it, and then various different solids. We have pickling salts, we have some dried beans, we have some popcorn kernels, and we have some sand. So we're going to start with the popcorn kernels and the sand. Now take a look at them. So the first thing we're going to do is pour the popcorn kernels into the sieve. There we go. And as you can see, the popcorn does not fall through the sieve. And now we're going to add the sand. And take a look at what happens. And if I shake it enough, the sand goes all the way through, and then I can easily put the popcorn kernels back into the container. So we're going to take that, and we've got in the bowl, I don't know if you can see that, all the sand. So we can make the sand go down back into its container, and we have successfully separated the popcorn kernels and the sand. Let's try these two, popcorn kernels and beans. What do you think might happen? Well, let's have a look. So we know that the popcorn kernels aren't going to go through the sieve. So we put the popcorn kernels in and nothing happens. Now we're going to put the white beans in, and here we go. And what happens? Not very effective, is it? We have now a mixture of beans and popcorn. The sieve did not separate them up. Think about other ways you could separate this. One way that you can separate it is by using your fingers and taking it apart, and that's time consuming, so we're not going to do that. Here's another one that we're going to try. We're going to take salt, that's pickling salt, so it's quite a coarse grind, and some sand, and we're going to try them and see what happens. So pickling salt, does it go through? Let's have a look. It does a little bit, doesn't it? And if I shake it enough, and now I add the sand, and I shake it, shake it, shake it, I still have a little bit of salt left in here, but I also have some salt that fell into the container. And if you take a look at this mixture, oh, I got a popcorn kernel in there, the fact that the way the mixture goes, it's going to be really difficult to separate this, and trying to separate this by fingers, you wouldn't be able to do. So unlike this one, I can probably put the popcorn and the beans onto a paper towel and separate them, but the sand and the salt, I'm going to have to just throw out because I can't separate them using my fingers. So think about that. And when you go back to your work, think about which solids we put together that we could use a sieve to separate, and also think about the solids we couldn't use a sieve to separate and why that happened that way. And the inference to that would be that if the particle sizes are very similar, you're not going to be able to separate them. But if the particle sizes, one particle size is large and one is small, it's way easier to separate solids. And so you're only going to be using sieves when you actually want to separate two solids with very different sizes of particles.